You got to be aware of the inbounder here if you're Philly.
It's off to Leonard, defended by Simmons. Is this the dagger? Game! Series!
This is the physics behind Kawhi Leonard's Game 7 Eastern Conference Finals buzzer beater.
For the first portion of this video, we will be analyzing this clip from when he released the ball up until it hits the rim.
When talking about the projectile motion of the basketball in this shot, we started with a couple of variables. For the X, we started with the fact that he was 7.01 meters away from the basket, which is 23 feet. We also know for the Y that the X naught would be 2.7 meters because that is how high he released the basketball. And the X would be 3.048 meters because that is how high 10 feet is in meters. We also know after numerous videos of watching Kawhi Leonard's shooting form, we can assume that he released it at 44 degrees. And the NBA stated that he released it at 12 meters a second during the shot. This led us to be able to solve for the velocity in the Y and the velocity in the X. So we took 12 sine of 44 degrees to get the velocity in the Y, which was 8.34 meters a second. And we took 12 cosine of 44 degrees to get the velocity in the X, which is 8.63 meters a second. This led us to be able to solve for time because V equals V naught plus AT. So we did 0 equals 8.34 minus 10t, and this led us to be able to solve time as 0.83 seconds from when he released the basketball to when it hit the rim. Next, we are going to analyze how long it took for the ball to bounce up after hitting the rim.
But wait, Kawhi likes origami. What'd you make, Kawhi?
It's a snowball.
That's a pretty good snowball, Kawhi.
Yeah, I know.
Now, we want to figure out how long it took for the basketball to bounce off the rim and come back down. How do we figure that out? We got you. While looking for information about how high the ball bounced, many sources state that the ball bounced approximately 1 meter high. We also know that the final velocity of the ball was 0 meters per second because it would be at its peak height in the bounce, and we also know that the force of gravity is always going to be negative 10 meters per second squared. First, we need to find the final velocity of the ball after it bounced back up. We can use the final velocity squared equals initial velocity squared plus 2a times x minus x naught equation. When we plug in the appropriate numbers into the equation, we get final velocity equals 4.47 meters per second. Now, using the initial velocity, we can plug that into the v equals v naught plus at equation to find the amount of time it took for the basketball to bounce up the rim for the second time. That's when we get our answer that the ball took about 0.44 seconds to get to the maximum height of the bounce and took approximately 0.894 seconds in total for the ball to bounce up and come back down.
Next, we wanted to find the energy lost when the ball bounced off of the rim. So to find the initial kinetic energy, we took 1/2 times the mass velocity squared. This gives us 1/2 times 0.635 kilograms, which is the mass of the ball, times 12 squared, which was the initial velocity. This brings our initial kinetic energy out to 45.72 joules. Then to solve for the potential, we took mass times gravity times height. This also gave us 0.635 times 10, which is gravity, and times 2.7, which was the release height of the ball. And the potential energy initially was 19.35 joules. Then the total initial energy, we added those two together and got 62.87 joules. Then to find the final kinetic energy after it bounced off of the rim, we took 1/2 mass velocity squared. We took 1/2 times 0.635 for the mass of the ball times 4.47, which was the initial velocity of the bounce. That gave us 6.34 joules as the final kinetic energy. Then to find the final potential energy, we took mass times gravity times height. Gave us 0.635 times 10 for gravity and times 3.048, which was the height of the rim. That gave us our final potential energy as 19.35 joules. Then we found that the energy final was 25.69 joules. And to find the change in energy, we subtracted the final energy minus initial energy and got 37.18 joules lost from the bounce.
Thank you guys for watching and have a great day.